Hello, today I will be talking about Physics 2211 Lab 3 over black holes and orbits. For a brief introduction of the lab and what we did, uh, or its purpose, it was split into two parts. Both were coding. In the first part, the objective was to analyze the star's motion to find the mass of the black hole as well as the net force on the star. However, for part two, the purpose was to utilize the mass found in part one to determine the ship's initial velocity. Um, and the goal was to be able to fly close to the black hole but not crash into it. For the fundamental principles in this lab, Newton's second law and the gravitational force were the two mainly the needed. Newton's second law basically relates the net interaction between system and surroundings to the observed motion of the system, meaning that the force acting on the system is equal to the change in momentum over time, which can be seen down here. For the purpose of this lab, we used the uh, the formula in terms of parallel and perpendicular, and then for gravitational force, that is the second image. Gravitational force is an attractive force that pulls items with mass towards each other. And here you can see we start off with the original formula, but you can manipulate it to find the mass of um, the black hole. Sorry, of the ship. And then we also utilize the position update formula. For part one code, here we edited the um, the parts for the arrows to make sure that the they would during the orbit they would not crash into the um into the hole, and also made sure that that the orbit would not crash into the hole, but also we were seeing like kind of like the trajectory with the arrows, which can be shown here. um the uneven um orbit, or like the black hole not being centered, can be a sign that the force is uneven in certain parts. For part two, here is the code that we edited. Here you can see um, the ship speed, and also we found the force in relation of the moon on the ship, the planet on the ship, then the net force on the moon from the planet on the moon to the ship on the moon. And here were the results of that. Here is the final velocity um, vector. And while we're here, potential sources of error are that finding the right values to plug into some of these was more trial and error than anything, so they may not accurately represent. However, this can also be maybe negligible because in the instructions it was said that there was no singular correct answer. For what does it mean for how is the net force and its parallel perpendicular components different from the rate of change of momentum and its parallel perpendicular components? The net force and the rate of change of momentum differ in that for the net force we need to know each force acting on the system. However, for the rate of change of momentum, we only need to know the system's change in velocity. And for the what if question, we are asked if we wanted to project the motion of the entire system, or would you need to include in the computation model? We wouldn't. I believe that we would need to include more solid values than just like kind of plugging in so that we can make sure that the orbits do not collide, or well, that in orbit they do not collide with each other or with the black hole. Thank you.